Okay, so we're going to move on to exercise 6D, and we're going to start off by looking at how circles and lines intersect with each other. So I'm just going to be looking at the left-hand side of this page to begin with. And I've said, recall that to consider the intersection of two lines, we attempt to solve them simultaneously by substitution, and then potentially using the discriminant to show that there are no solutions and hence no points of intersection. So that might be one way of showing that two things do not intersect. So generally, the pattern that we do is to do the intersection of two lines, we solve them simultaneously using substitution. We then come up with some kind of quadratic, and then we use the discriminant, and the discriminant will tell us a few different kinds of things. First of all, the one that we've talked about here is that there may be no intersections. And what I'm trying to represent is if this was our circle and this was our straight line, clearly that straight line is not intersecting anywhere. And that would only be true if b squared minus 4ac was less than 0. Because remember, that's the part that the discriminant, this is the part inside the square root. And if it's less than 0, you're not going to have any real solutions. Then we're going to have a look at this section, which is if you have a straight line that is intersecting clearly at two different points. So this is our two intersections, and I've written here that it's two intersections such as a line, sorry, such line, I shouldn't say such a line, such line is known, or such a line, is known as a secant of the circle. So this is a secant of the circle, that orange line, and this would be if in that resulting quadratic that b squared minus 4ac is greater than 0. And then we get down to this interesting one because we have just one intersection, and this is the idea of this, sorry, such a line as this is known as a tangent. Yeah, I guess I really shouldn't have got rid of that. So this is known as a tangent of the circle. You know, I've come across this before, and we know there's some really interesting properties of tangents, that the radius and the tangent meet at 90 degrees. And so later on in this chapter, we're going to be using a lot of that information to try and logically reason about how to solve some of these problems. So if it's only meeting at one point, then we would say that b squared minus 4ac is exactly equal to 0. And we've talked about that before. I think the last time we spoke about this, we talked about it with like quadratics, where it could either cross in two places, in no places, or in one place. So it's exactly the same idea. We've got two places, one place, or none. Here we've got it could cross in two places, one place, or no places at all. Okay. So let's just actually dive in and straight go into some examples with this. You'll find the quadratic equation solver in your calculator is going to be very useful here. So we've got show that the line y equals x plus 3 never intersects the circle with equation x squared plus y squared equals 1. So the steps that we're going to do here is we are going to solve simultaneously. And what that will do is that will produce a quadratic. So this produces a quadratic. And then what we're going to do if we want there to be no intersections is we're going to, for that quadratic, we're going to show that b squared minus 4ac is less than 0. And I suggested over here that the best way of solving this is to do substitution. So I'm going to take this y equals x plus 3 and I'm immediately going to substitute it in here. So I'm going to solve this equation simultaneously. So it's going to be x squared plus y squared. Well, y is x plus 3. So it's going to be x squared plus x plus 3 squared is equal to 1. And I'm just going to do some bracket expanding. So I've got x squared plus 6x plus 9 equals 0. Now I do 2x squared plus 6x. Oh, doesn't equal 0, does it? My mistake. It equals 1. And that is going to be plus 8 equals 0. Now, what you might be tempted to do is just to put this into your equation solver and to show that it doesn't have any solutions. And when you put this into your equation solver with a as 2, b as 6, and c as 8, you get imaginary numbers. You get some complex numbers that have got I with them. And that's not the best way of showing that this doesn't intersect. In fact, what you need to do is you need to use the discriminant here. So we're going to use the discriminant. So clearly A is 2, B is 6, and C is 8. So we're going to work out what B squared minus 4AC is. Now B squared minus 4AC is going to be 6 squared minus 4 times 2 times 8, which is equal to, if I just try it on here, so that is 6 squared minus 4 times 2 times 8 and we get minus 28. So this is minus 28, which is less than 0. Hence, as b squared minus 4ac is less than 0, the line never intersects the circle. And I'm just going to quickly show you that on Desmos. So one of our lines is y equals x plus, 3, and the other one is x squared plus y squared equals 1. And very clearly, we can see that there are no intersections with these, okay? So let's have a look at a couple more examples. This one is nice and easy. It says find the points of intersection where the line y equals x plus 6 meets x squared plus y minus 3 squared equals 29. So there's a clue in the question. It says find the points of intersection. That means there's going to be more than one. So I'm going to take this and I'm going to substitute it in place of y. So we have x squared plus y is x plus 6, and then I've still got the minus 3 squared equals 29. And clearly here we've got a quadratic. So that's x squared plus x plus 3 squared equals 29. That's x squared plus 6x plus 9 equals 29. So that's 2x squared plus 6x. Now we're going to do 9 minus 29. Am I really going to use my calculator? Yes, I am. Equals 0. Now we don't even need to solve, we don't even need to do any factorizing, because actually we can just go straight to our calculator and we can say that a is 2, b is 6, and c is minus 20, and it will solve it straight away for us and tell us that x is either equal to 2 or x is equal to minus 5. Now that isn't actually the end of the question, because we need to find the y coordinates as well. So we need to find the y coordinates. Now we know that y is equal to the x coordinate plus 6. So if x equals 2, y equals 2 plus 6, which is 8. So one of the coordinates of intersection is 2, 8. Now, if x is equal to minus 5, then y would be equal to x, which is minus 5, plus 6, which is 1. So the other coordinate would be minus 5, 1. So our points of intersection are 2, 8, and minus 5, 1. I guess the only thing that I've seen people do badly in the past with this is they might say like x equals 2, y equals 8, x equals minus 5, y equals 1. And it's not clear. Are these two together? Are these two together? Are these two together? So it's just got to be, you've got to be really careful about the way that you give your answers, and you should give them as coordinates. So I'm just really quickly going to show you this on Desmos. So we've got x squared plus y minus 3 squared equals 29. Let's see if we can just edit this. Plus y minus 3 squared equals. And you should do this when you're solving questions to actually see what's going on. And it's really nice to visualize what's happening. So the coordinates where they intersect, we've got 2, 8 and minus 5, 1. And that is exactly what we've got, 2, 8 and minus 5, 1. Okay, let's have a look at the question that I've got on this side. Using an algebraic and not geometric method, a geometric method would be through drawing diagrams. Determine the k such that the line y equals x plus k touches the circle with equation x squared plus y squared equals 1. Okay, so I just want you to think to yourself, if it just touches the equation, the circle, sorry, what do we know about the discriminant? Okay, hopefully you know that the discriminant is going to be like this. It's just touching at one point, so the discriminant is going to be equal to 0. So although we've got a value here that we don't know, this k, we're just going to proceed with this whole question as though it was just a number, and then we're going to use the information that b squared minus 4ac equals 0. We're going to use that at some point to find out the value of k that makes it a tangent. So let's have a go. We're going to do the same thing of doing the simultaneous equations. So it's going to be x squared plus y squared. Now y squared is going to be x plus k squared equals 1. And we're just going to be carefully expanding the brackets here. If you need to, you could always do your x plus k and expand them slowly, but I'd rather you see if you can just expand them directly. So we would get x squared plus 2kx plus k squared equals 1. Simplifying, you get 2x squared plus 2kx plus k squared minus 1 equals 0. Now, although you might not necessarily see this, this is indeed a quadratic. We have the a term, we have the b term, which goes in front of the x, and we have the c term, which just happens to be two terms together. So in this case here, a is 2, b is 2k, and c is k squared minus 1. Now, because it's just touching it at one point, we are going to say that b squared minus 4ac equals 0. And we want to write that down. B squared minus 4ac equals 0. So careful when you do b squared, you're going to have to bracket the whole thing. And you've got minus 4 times a times by c, which I'm going to bracket as well because I want to multiply it by the whole thing. And we come up with this. So 2k squared is 4k squared. And then we've got minus 8 times 8k squared, which is minus 8k squared. And then we've got here minus 8 multiplied by minus 1, which becomes plus 8. And that is equal to 0. So we've got 4k squared minus 8k squared. That's minus 4k squared plus 8 equals 0. I'm just going to zoom in so I've got a bit more space. So that means that 8 is equal to 4k squared. Divide both sides by 4 so that we get k squared is equal to 2. And so that must mean that k is equal to the positive or negative square root of 2. K could be plus or minus 2. Okay. Now it might say in the question that k was greater than 0 or less than 0, in which case it would help you to decide. But in this case, there are two values of k, and I'm going to show you that by going to Desmos, because I really like to use Desmos for these kinds of questions. Okay, so first of all, the equation of the circle is just x squared plus y squared equals 1. And I think it was y equals x plus k, right? Let's just double check that. Y equals x plus k. Great. So one of the things we said that k could be would be the square root of 2. So here it is. We have it just touching the circle just here. And the other thing that we said that k could have been, instead of it being plus 2, why not put them both on at the same time? Y equals x minus the square root of 2, because that's the other value of k. And there you go. You can see that both of those lines are just touching the circle in one place. If we change those values just a tiny bit, you would see that they either don't touch at all. So if I go here and I zoom in, they actually don't touch. And you can see I've just changed it just such a tiny amount. And actually, if I wanted to, if I changed it to the other direction, so it was 1.99, you can see it's then going to cross it at 2 points. We're getting it crossing here and here. So it's when it's the square root of 2, it only crosses at that 1 point. Okay, so there are many different ways they could ask these kinds of questions, which my next example demonstrates. You might like to have a go at doing this one yourself, because part A of the question is pretty nice. It recaps some of the stuff from exercise 6C, and then part B of the question is stuff to do with the video that we've just been doing. So if I were you, I would pause the video here and have a go, and in just a second, I'm going to be going through this one. Okay, so we have this equation of a circle that's written at the top, and for part A, it wants us to find the center and the radius. And when it's written like this, 1 and 2, it doesn't really matter which way round you do this. They don't look for it in a particular order when they're marking it. So let's just go with part A. We'll write it all together. Now, if you remember, you rearrange it so that you have x squared minus 6x. You collect the x's and x squareds together, plus y squared plus 10y plus 9 equals 0. And then you complete the square. So you get x minus 3 squared, but counteract the 3 squared by taking away 9, plus y plus 5 squared, but counteract it by taking away 25 because of the 5 squared, and you have plus 9 equals 0. Well, the ones we'll spot, you can do the plus 9 and the minus 9 will just get cancelled straight away. So we get x minus 3 squared plus y plus 5 squared is equal to 25. So the center is going to be 3 minus 5, and the radius is going to be the square root of 25, which is 5. So we've got those first 3 marks for that question there. I'm just going to add in a blank page so I've got a bit more space. Now it says the line with equation y equals kx, where k is a constant, cuts C at two distinct points. So it's cutting the circle at two distinct points, and it wants us to find the range of values for k, not an exact value, but a range of values. Now, if we've got a circle and it's cutting it at two distinct points, we know to do with our discriminant that we've got up here, out of these three scenarios, this one, or this one, we're referring it to cutting at 2 points. So we want the discriminant to be bigger than 0. So this is kind of a nice revision from some of the earlier stuff we did on the discriminant. So I would like to just jot down, we want the discriminant to be greater than 0. So let's just dive in with our question. I am probably going to use it doesn't really matter if I use this version of the equation or the original one. I'm probably going to use the one the original one actually. I think the original one's probably going to be easier because it's already been expanded. So we've got that y equals kx, and our other equation is x squared minus 6x plus y squared plus 10y plus 9 equals 0. I think it's going to be easier to substitute in here. So that's x squared minus 6x plus y squared, which is kx squared, plus 10y, which is 10kx, plus 9 equals 0. So that's x squared minus 6x plus k squared x squared plus 10kx plus 9 equals 0. And I'm just going to collect together the like terms now. So we've got x squared plus kx squared. I'm going to take it a little bit slower. X squared plus k squared x squared. And then I've got plus 10kx minus 6x. I started with the 10kx just because I prefer starting with a plus rather than with a minus. And then I have plus 9 equals 0. Now, you may find it easier to actually factorize this. So if I factorize out the x squared, I would have 1 plus k squared for these first two terms that I've got here. And then if I factorize out the x here, I have 10k minus 6 for these terms. And then I have plus 9 equals 0. This is definitely more demanding than the previous ones. So this is my coefficient of the x squared. This is my coefficient of x, and this is my constant coefficient that I've got here. So a is equal to 1 plus k squared, b is equal to 10k minus 6, and c is equal to 9. Now remember what we wrote here. We want that b squared minus 4ac to be greater than 0. So b squared minus 4ac is going to be greater than 0. So we have 10k minus 6 squared minus 4 multiplied by a multiplied by c is greater than 0. So 10k squared is going to be 100k squared minus, well, you'd have the 6 times 10, which is 60, but you're going to have that twice, minus 120k. And then here you've got the 4 and the 9, which is 36. So you've got minus 36. 1 plus k squared is greater than 0. Although it's weird numbers, this is still just a quadratic equation. So we get 100k squared minus 120k minus 36 minus 36k squared is greater than 0. So let's just do 100 minus 36, which is 64. So we have 64k squared. We've then got minus 120k minus 36 is greater than 0. Now, if you have the ClassWiz calculators, you can actually just put this inequality straight into your calculator. I don't think the graphics calculators can do this. So instead, what we're going to do is we will solve the equation 64k squared minus 120k minus 36 equals 0, and then we'll sketch it. So I'm going to put in, I've got 64, we've got this quadratic within a quadratic. It's quite crazy, but it's going to work out. So I'm going to put in 64 for A, minus 120 for B, and minus 36 for C. And we get some rather unpleasant numbers. I just want to check, are these the right kind of numbers? Oh man, what have I done wrong here? I think I might just type something into my calculator wrong. Let me just double check this for a second. Did I expand this bracket? Oh, I see what I've done here. Hopefully what will telling me that I made this mistake, because I definitely spotted a mistake that I made, and it was all the way back here. Have you spotted the mistake I made? The mistake that I made was in expanding this. I didn't finish expanding it. 100k squared minus 120k, but I forgot about the minus 6 being squared, which was that plus 36. So I'm hoping that you spotted that quicker than I did. My mistake, guys. So I have plus 36. Now when I expand this, I get minus 36 k squared. Oh, I hope you were screaming at the video telling me, what's he doing wrong? Okay, so these cancel. So we then just get 64k squared minus 120k is greater than 0. So what I'm actually going to do, I'm going to go back to this and hopefully this will be working much easier. I'm actually going to solve this equation first of all. So if I factor out the k, you could either use your calculator or you could just factor out the k here to find out where it's going to cross the axis. So either k is equal to 0 or k, 64k is equal to 120. That's from this bit. So k is equal to 120 divided by 64, which is 15 over 8. So when we do the sketch for this, we can see that the places it's crossing is going to be at 0 and 15 over 8, and it's a positive quadratic because of the fact that this number here is positive, and we want it to be greater than 0. So the places where it is greater than 0 is this branch and this branch, which therefore corresponds to these numbers or these numbers. So I'm just going to zoom in here. This is 15 over 8, so we want it to be 15 over 8 or bigger, or we want it to be 0 or smaller. So the range of values that k can be, and I might do this just like this. So for the k that k can be, is k has got to be less than 0, or k has got to be greater than 15 over 8. Now remember, they might ask you to do that in set notation, in which case you would be saying something like k such that k is less than 0, or k such that k is greater than 15 over 8. Sometimes we say k is a real number such that k is less than 0. I think that's probably how we did that before. But that's set notation in case they ask for it to be in set notation. But in this case, they didn't, so it's perfectly fine to give it just like this. Hope you didn't make the mistake like I did with forgetting the plus 36. Let's just check on the mark scheme. So we got the correct center and the correct radius, and we've got the k is less than 0, or k is greater than 15 over 8. Okay, so that's enough work to be able to help you to do exercise 6D now. I hope that goes well for you. Thanks.